section 1.6, classify polygons. Our goal is pretty simple. It is to be able to classify polygons. So we start with, what is a polygon? A polygon is a closed plane figure with segment sides. So we draw some things here. Now, granted that I cannot draw a perfectly straight line, but this is called a polygon because it is closed and it has segment sides. Each of these points is called a vertex. So that is what is a polygon. Things that are not polygons. Something like this. There are two figures. That is not a polygon. It has to create one figure. Another example of what we will see is something like that. It's open. That is also not a figure. Something that looks like an ice cream cone. Sorry, but the rounded part is not a segment. Circles. No straight sides there either, so circles are also not a polygon. For things that are polygons, there are two types of polygons. It is either convex or concave. It is one or the other. Convex. We will say that all points, so all vertices, vertices is the plural of vertex. We don't say vertexes, we say vertices. So all vertices are on the exterior. Or another way of saying it, all diagonals inside polygon. So if I look at something like this, for example, if I were to draw any of these diagonals from vertex to another vertex, I would see that they are in fact all inside. I do not leave the polygon. That is convex. Concave is where a diagonal go outside of the polygon. Creating what we call a cave-like entrance. So something like this, for example. If I draw this diagonal right here, that goes outside of the polygon. Yeah, some of these go inside, like if I draw these ones, they go inside. But if I were to draw this one also leaves. As long as one of them goes outside, it's called concave. And when we talk about your cave entrance, there it is. There is a cave entrance. It kind of looks like Pac-Man a little bit. Alright, so one way to classify them is convex or concave. The other way to classify them is by the number of sides. So we'll simply go through this quickly here and name all of them. So a three-sided polygon, we all know, is a triangle. If it is four sides, we call it a quad, prefix for four. And then a quadrilateral meaning four-sided. If you simply call it a quad, that is fine. I will reference it as a quad. The prefix for 5 is penta. And then we add gon on there. So a 5-sided penta for 5, gon for polygon. So a 5-sided polygon is a pentagon. 6-sided hexa. So we have hexagon. 7 is hepta. So we have a heptagon. 8 is octagon. 9, nonagon. 10 years is a decade. Deca is the prefix for 10, so it's a decagon. 11 we are not concerned about too much. 12 is dodecagon. And anything 11, 13 or more, we just simply say the number and then gon. So 20-sided polygon would be a 20gon. So classify each polygon below as concave, convex, and by the number of sides. The first one here we look at is clearly concave. And we count the number of sides. It has 7, so that makes it a heptagon. The next one here, all points are on the outmost side, so it is convex. We count up, it has 6 sides, so that means it is a convex hexagon. We look at the next one here, the check mark, cave entrance, so it is concave. And we count the number of sides, also has 6 sides, so it is a concave hexagon. Other terms associated with polygons. Equilateral. Equa, prefix meaning equal. Lateral means side, like a lateral movement is a side movement. So equilateral simply means all sides equal. You'll see me abbreviate it with equilat. Equiangular, same thing, all angles equal. And lastly, the term regular will mean all sides and angles are equal. So it has to be both. It can be equilateral without being equiangular. It could be equiangular without being equilateral, but if it's regular, it has to be both. So if something was 5-sided, all sides are the same, all angles are the same, we would say it is a regular pentagon. A rack for billiard balls is shaped like an equilateral triangle. That means that all sides are the same. Find the length of each side. Well, if we know the sides are the same, we will do like we've done before and say that since they're the same, they're equal to one another. And we will go ahead and solve. And we solve for x. Does this problem ask us to solve for x? No, it says to find the length of a side. So you can pick whichever one you want. I like working with positive numbers, so I am going to use the adding method. So 4 times 3 plus 2, I get 12 plus 2. So we get a side equals 14 inches. Make sure you are labeling when working with these problems. says find the perimeter of the triangle. We know each side is 14 times that there are 3 sides, and that we get the perimeter is 42 inches.